welcome to this roundup. As fiber optic technology revolutionizes telecommunication and is proving to be a more efficient means of transmitting both data and voice, the fifth generation wireless network of mobile internet connectivity offering faster speeds and more reliable connection to mobile devices is also here. While 5G networks are expected to help power a huge rise in mobility and the Internet of Things technology, providing the infrastructure needed to carry huge amounts of data, allowing for a smarter and more connected world, the debate is emerging about the future of 5G network. To discuss the rapidly evolving 5G network further, I'm delighted to welcome Dr. Ahmadreza Rofougaran to this roundup. Dr. Reza is a leading pioneer, engineering executive, inventor, and entrepreneur in the wireless communications industry. He's also the co-CEO, CTO, founder, and board member at Movandi Corporation, developing 5G wireless network systems based in the United States. Prior to Movandi, Dr. Reza was co-founder of Innovent Systems and is one of the top 10 patent holders in US and top 20 patent holders in the world. Dr. Reza is a fellow of IEEE and Broadcom and was influential in starting and building the wireless business at Broadcom that shipped in excess of 1.5 billion radios per year. Dr. Reza holds over 800 issued patents. Welcome, Dr. Reza. We are so very honored to have you on Risk Roundup.
Thank you very much. Yeah.
Wonderful, Dr. Reza. So it seems that the fiber optics revolutionized the communication technology by allowing the transmission of greater data capacities for considerably longer distances with less interference than the traditional copper technologies that we have been using over the years. Now, amidst this parallel revolution and evolution in fiber communication technology, where do you think is the evolution of wireless network from 4G to 5G is taking us?
Well, the 4G to 5G is similar revolution that happened in wireline. That the influence that or the effect that fiber optic had on the communication. So it had a lot of effect. One effect was basically voice over IP that you're using every day. We used to have, if you had a long distance call, you had to go to satellite. Now, now you do everything on fiber. As in much faster, you don't see echo, much cleaner. The other thing is today's internet traffic that you have, almost every new company, including this new generation of the company that you use every day. It's possible because of the fiber optic, because it's so quick and so fast that you can get the data, or you can get the communication link within a matter of milliseconds, and then get the information. You don't use library anymore. You just use everything on the Google, or you do search. It's all possible because of the fiber. If you look at back in 90s, there was the internet started, but the speed was so slow that it was almost impossible to do what we do today. So what 5G brings is basically a step that they did, the fiber optic did to that such a step is going to happen in the wireless industry. So now you can have low latency and so quick access to the data, to different places, to data, or you can transfer data so quickly back and forth that basically it's real time. So now the mobile devices, while you're moving around, you will have such access, and you can have. And it basically create a new a revolution, especially in the basically being so quick or so fast connection to the cloud that basically everything can run on the cloud. And I think on the new generation of the artificial intelligence, it's all based on the cloud base, because it gathers your data so quickly, and you can actually communicate with your devices so quickly, or with you, but at the same time has a lot of data from other users or other places, which basically the system or the processor of the running on the cloud can actually make a better decision and much smarter decision. So it basically revolutionized the way that we will be living in the future, and we're going to get much more intelligence information from the servers and cloud. And you can see to some extent it already happened. If you look at your GPS, global positioning, if you look at back 90s, it was just basically a program running on your car, and it was giving you navigation. It didn't have any information regarding traffic and about the traffic lights or any other information. Now the GPS that you're running today is very smart. It had the information about the traffic lights, every information, and then basically pass it to you. So when you actually going from one place to other place, is not just the navigation. Sometimes you use GPS because you want to know exactly what time you're going to get there, which is the best route. But so those information is coming because all coming is already in cloud. It gather other information in other places, and it's feeding back to you. So the same thing will happen in the wireless industry. Basically, every information that goes to the cloud coming from you or from other places will be used to basically give you much better information or smarter decision-making system. Yeah.
Yes, no, that's an excellent point, that information and intelligence is becoming much more easier, and it's letting us have that, the whole smart ecosystem that we have always been looking for. But if we look at, it seems that 4G macro cell towers, so far, they relied on the radio frequency spectrum. They were able to travel great distances, reducing the number of towers. We didn't need so many towers. I mean, we had towers at distances, so the need for number of towers was less. But 5G, it seems that it's different because now it relies on higher frequency millimeter waves and cannot travel probably more than 200 feet, right? So it how do you see this forcing the telecom companies to change their approach as far as their infrastructure goes?
Yeah, this is not just because we're going to millimeter wave, it's because you demanding higher data rates. So basically, the issue is because you demanding much higher data, about 10 to 100 times faster. That means you need more to receive much higher power compared to, the level that you can support lower data rate. So in general, even if you go lower frequency and you want to basically increase data rate, you have to increase the amount of power, or you have to shrink the distance between the units. So that's by physics. Basically, whenever you're demanding more higher data rate, you either have to deliver higher power or you have to shrink the distance so you receive higher power for your communication. That's basic physics. But at the same time, when you're moving from millimeter wave to for lower frequency millimeter wave, then basically the behavior is a little bit different, because at lower frequency, when you're transmitting signal, the signal, it's basically propagating everywhere. It's just like, when you have when you throw a stone in the water and you see the waves start building up and grow and grow. So the same thing happens at lower frequency when you're transmitting. It's like a balloon. The signal start, expanding like a balloon and goes everywhere. But the fact that you're receiving at every location is not because they're expanding like that. It's because the wavelength of those lower frequencies is much longer than millimeter wave. So if you look at I give you an example, like, for example, if there is if there's a wave in the ocean, and then there's a rock in the middle of the ocean. When the wave hit the rock, you see it splash the water everywhere. So at lower frequencies, the same thing, because the wavelength is long. When it hit at every corner, it basically splash all the power every location. So it's called scattering, or basically the way that basically the signal gets splash everywhere. So that's how you get you receive the signal at every location and you have a good coverage. At the millimeter wave, the wavelength is much smaller, so it will act more like a light and like a laser. When you shine a laser into the mirror, it doesn't go. It only go one place. It only get reflected one place. It doesn't shine the whole area. So basically, when you go to millimeter wave, the wave travel, but the way that it travel, if it hit at every corner, it would not scatter. It would get reflected. So that actually reduced the coverage. That in a way that if you're not in the path of the wave, you won't see it. So now the issue is how to enable the millimeter wave to have the same coverage. And then there are a lot of different proposals. Is basically you control the wave that it gets to you, like, kind of like what radar does, is basically track you. Or there are other ways of doing it that Movandi is doing anyway. So the difficulty of the millimeter wave to get it to every location is basically be able to get the signal the place that you are efficiently. So that's one difficulty. The fact that you need more tower is because you need more power. You need to deliver more power. Yes, that's true. You need to have more base station. Even if you look at the LTE, compare the number of the base station that the LTE requires compared to GSM that was 20 years ago, GSM didn't have much tower. It was like, several mile, even longer distance between them. But the LTE had required like a mile, less than a mile distance between the base station. So the same thing in millimeter wave, you need more closer distance between the base station or small cell. So the way to do it is basically you need to make those station is much lower cost. So similar to what access point for Wi-Fi has. The reason that you see a lot of access point everywhere, if you go travel in the street and you look at you open your setting on your iPhone, you see like 10, 20 of the wireless access point around. You cannot connect to it because you need a passcode, but the fact that there is so many access points, because this access point costs only $50, $100, or $150, and everywhere now you see it everywhere. So if the price of those small cell come down to the range of a few $100, then it will not, the cost of the hardware would not be a big challenge. The only challenge is the location that you may have to pay your rent, or if you need to have a fiber backbone, because there's all the small cell and base station require the backbone fiber. So the cost of the fiber, if it is not available, then you have to basically draw the fiber to that location. If it's available, the monthly that you have to pay for the fiber cost, and also the power and location that you have, the rent. Those actually become more bottleneck than the actual hardware cost. So how to address that? Then basically, Movandi has a solution to basically reduce the cost or the impact of this on the system, as well as to increase the coverage for every location. So those are the challenge that the millimeter wave is experiencing and is not picking up as quickly because they have to overcome this challenge. Yeah.
Right, right. No, I hear you on that. I understand. You just explained that how it's going to be beneficial for the AI, because if all the data is in the cloud, it will be much more easier to analyze it and to get the intelligence out of it. So that is one need that it seems it's going to meet, and also the IoT requirements. It seems it's going to meet the requirement for IoT also. But one question I have is that what about the EMP, electromagnetic pulse, protection? Will the 5G network be resilient to the EMP if there is an attack?
The attack to, what do you mean, the health? No.
If, let's say, there is a EMP warfare going on. We just read in that Washington, D.C., we were preparing for that. So,
well, the attack is kind of, there are different ways. You can jam it and then disrupt their communication, or you try to steal their communication and then try to, hack it in a way that you basically give wrong information. The jamming is basically you have to generate a lot of power in the same frequency. So, in the same frequency, for example, that you're operating, if somebody deliver a lot of power at that frequency, then basically it creates an interference, and then you start see a lot of noise or disruption on your communication. That has been, if you see in the military, in the FAR, basically they use a lot to jam the GPS and other communication they have. Well, that can happen, but the thing is about these is to be able to disrupt the 5G. It's as I said, the power has to get concentrated in a way that the location that the signal is traveling, right? So if they try to jam, let's say, the communication between me and you, the communication between me and you is going to be like more than think about like optics, like a laser, right? So if somebody jams it in the wrong direction, me and you never experience it. So they have to jam it exactly to the place that I'm delivering the power, right? So if efficiency can do that, then basically they can disrupt the communication. But look, there are so many devices around, right? So to be able to jam all of these, they have to deliver a lot of power to every user. So it's going to be more difficult at lower frequency, because lower frequency, when they jam, the signal also goes as the same way that it have travel everywhere and it available everywhere. The jammer also becomes the same way. It easily goes everywhere. At more millimeter wave, it has to be more targeted. So if it's one-to-one communication, maybe it's easier, because then we can say, oh, this is the location and deliver power, and then another source of jammer will do the same thing. But if it's a distributed system that goes everywhere and communicating with a lot of it, it's going to be more difficult to do so, because it requires a lot of power to do those jammers.
Right.
So
No, that is a good point that it requires a lot of power. But is it technically possible to secure the entire network, make them EMP resilient?
yeah, so what I do is basically you would create diversity. So if there is a sensitive area that basically you want to receive the power signal. So if you have the location separate enough that basically when I deliver different ways of the communication to you. So let's say there is one antenna with in 5 meters apart or 10 meters apart, and if I'm basically communicating with both of the antenna, and then I delivering power into both. So the jammer has to jam both of them, not only one of them. So basically, the jammer has to know how many antenna I use and where the location are to be able to jam on that location. So by kind of diversity and kind of like a smart way of basically delivering the signal, you can confuse the jammer. Jammer has to become smarter and smarter to be able to communicate, disrupt the communication. So the millimeter wave disruption is not as easily.
Not
As a matter of fact,
just,
if you
sorry,
look
not
at
just
some,
voice communication, but also data communication, right?
yeah,
Because
basically.
it's the data we want to protect.
Yeah, so if you look at, for example, if you look at in future, the service provider, they actually have the base station close by. And the way that basically they are able to operate, because they beam two different ways. Like one beams on the, from the right side, one beam from the left side, and then they come both to your location, to that area. But because the receiver locked to the one of the base station with the beam, then it may kind of filter the other one. So the other one to be able to jam you, it has to deliver much higher power, maybe like 10 times or 20 times more power just to you. So imagine that you have so many users around and you want to do the same thing, or so many receiver around, you want to do the same thing. Basically, they have to do exact similar opposite beamforming to every location to be able to disrupt the communication. So I don't think that being worse than what happened at lower frequency, if not better. The communication can be actually, I think to me, is not going to be worse than lower frequency. It's actually provide more immunity at millimeter wave than lower frequency. Lower frequency is much easier to do this kind of thing. Yeah.
I see, I understand that. Now, I read somewhere that the network level signaling is the same in 5G as it was in the 4G and 3G based on the diameter signaling. Now, it is believed that the technology of the mobile network core will be comparable or, almost similar to with the with the 5G, not Fiji, sorry, with the
Yeah.
5G, as has been seen in all these previous generations of 4G and 3G.
Yeah.
So, what's the network architecture in 5G? Is there any change in the network core, or is it just the same?
No, because the mobile system has to have the earlier generation also support this. So if you see the LTE and then 5G, they have to coexist in a way that basically mobile devices may actually communicate first through 4G, and then the data get handed over to 5G on the demand, or basically if it decide to do that, or if there are 5G base station around, then it will switch you to 5G enable. So having the previous generation, especially LTE and 4G, is masked because many reasons. One is basically you don't want to basically go to 5G, because 5G to basically locate the base station, it requires a lot of like searches and beamforming, which basically take longer and have more latency. The 4G is wherever you go is supposed to be accessible, so it's just basically it's much easier than when you receive a call or when you want to communicate. First set up the 4G link, and then basically from there you switch to 5G. So most of the mobile would not be 5G only. You're going to have a previous generation on it. The fixed location one that they basically compete with the fiber, or they're competing with cable to your home or to your office, they can be standalone 5G. But for the mobile communication, I think the previous generation of having the mobility based on the LTE and 4G, and then based on the demand changing to 5G, or when 5G is available, I think it's going to be there for a while. I don't think there will be a switch all to 5G device only. So because of that, then they have to sync together. The whole network has to basically sync.
Yes.
So basically with 4G, and then 4G with 5G packet and all this has to basically get synced to be able to switch back and forth. So that's,
Yes.
yeah. So that's what we say the previous generation, yeah.
You're right, because not everyone is going to have the 5G infrastructure everywhere, and not all the equipments are going to be able to receive 5G communication. So that
and that's true. If you go to a different country and different area, you see LTE become 4G and some area become 3G.
Yes.
So back and
that makes sense. No, that makes sense. So if we, apart from the speed and the bandwidth, are there any other major differences between 4G and 5G?
The speed and bandwidth. Okay. Well, the speed is a major thing because it will provide the quick access to your cloud. So in future, effectively, all your devices like a display, right? The same thing as you're most of doing with the computer. Everything is run on the cloud. So the speed is a major thing, but the latency is another thing. So the latency is what I mean. Latency is be able to basically quickly transmit back and forth in a very quick way, basically in a way that you basically for many applications like artificial intelligence or security, or you want to have a low latency, you want to get the data back and forth quickly. So you don't see that such a low latency in other systems like a 4G or 3G because it's the latency. Because of the packet and the way that the signaling goes, there is a higher latency. In 5G, if you have to do a lot of beamforming and beam management, then there will be a latency. But luckily, with the different architecture, actually you can get, you can overcome those, and the latency of that can be reduced to very minimum, to the level that you can actually enable all of these applications. So beside the speed, the latency is important. And what I mean with the latency, like satellite communication can be very fast, but the latency is high. So basically you can't get the same thing with the satellite. The latency of going back and forth with the satellite is not, if you demand something, you won't see it right away. It takes longer. But with the 5G, if you demand something, it's just like transparent, it's quickly come back. So the latency is another beside the speed. And then the effect, and effectively in future, if you do the architecture of the 5G correctly, in the right way, you basically not only can do better coverage in I can add this later on, better coverage, but more efficient. It can actually become more efficient in the communication than LTE. So it can actually help the battery life and the way that we're using the communication today. It can improve if it's designed correctly, or if and the architecture is correctly. It gives you that capability. Also, it provides much more capability compared to other thing that, like, I can communicate directly with you, or the devices have much more the system have much more capability than lower frequency. So if I want to directly communicate with you, I can put you in contact with me, and then we don't need to go through the whole infrastructure. Me and you can die. So there's a lot of new features that added to the 5G that does not exist at previous generation. Or if it is, it was not as efficient. But this 5G make it very efficient.
Right.
And also the 5G system, if you design it correctly, it can be dynamic. For example, if you wanted, for example, have a coverage at the stadium or some area that basically all of a sudden get crowded, you can actually provide the link, communication link with dynamic devices such as drone, or devices like mobile devices that temporarily can actually locate on those locations and provide the 5G connectivity. So that makes it more capable compared to lower frequency.
Yes, I understand that. Now it seems that today's 5G networks are designed to accommodate the enormous data, exchange that needs to be that will be happening because of the IoTs.
Mhm.
Now, are there any technical challenges that still needs to be solved for the 5G to be very effective for the entire IoT ecosystem or Internet of Everything ecosystem, or that it will be able to, no matter what comes next, other than voice and data, that it will be able to transfer
Mhm.
with this 5G architecture that we have, or is there a need for any architecture shift to enhance the delivery of what will need to travel through the network in the coming years?
Mhm. Well, I mean, the 5G, okay, the IoT device is not something new. It's actually the basic concept of it goes back in, they call it RFID back in 90s or early 2000. RFID, RF identification is supposed to be a tag that you connect to every device, and then you can locate it or you can store information that you can read the. So the IoT is more advanced of that because now you can actually communicate more. Not only as a tag, you can also communicate with the sensor, or some even send a command and back and forth. So it's kind of like a low frequency or like low end communication to device, the passive devices or control devices. So now because of the advances happening in a lot of communication, like having low power Wi-Fi, low power LTE, or Bluetooth, or is Zigbee, and the fact that not only they are low power, they are very low cost. It enables to connect those to every devices, or every piece of equipment that you have, or every even piece of furniture or anything you have, and be able to smartly control or collect data from those units. So now what it means that when you do that, then now you have a lot of data to basically read or write. So what it means, that means that you need a higher speed transport units, right? So that's what happened in fiber. Why fiber all of a sudden was pushed, because a lot of like VoIP or a lot of other applications start putting a lot of data into the system, and the wireline could not handle it, and fiber could do it. So now 5G brings the same thing to the system, because a lot of data that you collect or you communicate to these devices, that will be huge data. So 5G can have the bandwidth to deliver those data. At the same time, when you get those data and then goes to the server may have to collect all of those data, store it, and thanks to all of these memory advances that happen in the silicon memories that compared to those hard disks that it was had before, now you can store a lot of data and quickly read and write and then process them. So all those data coming from IoT or different places can also process and then back to users. So now you can see not only you collect and communicate with the IoT devices, you may actually collect all of the data and have to basically reconfigure them and process them and send it back to you in a way that you make it better, smart way. Like, for example, if you want to have a traffic, if you apply such a system into the traffic system, so basically every data collected from every sensor of the cars, automobile that you may have, and also the videos or images that you collect in the street and other information that you collect on that environment can go to the server and then can process and then get feedback to every car. So now you can actually control the traffic. You can synchronize the traffic. You can make sure that the car coming 10 miles away, by the time you get to this intersection and you get into the intersection, you basically minimize the accident. So the whole traffic system can be actually synchronized, and then be a more secure system can be applied. So, and then you can also minimize all the issues of the if there is robber, I mean, all the criminal action, you can also quickly see and then apply quickly the decision. So it's not only the service that you do, also minimize other things that that can happen, and then you prevent those things happening. So now the 5G, because it's collecting mobile data, it's fiber cannot do that. Things are moving around and they're collecting all the data and you're putting back and forth. It actually will revolutionize that. So the fact why 5G, because of the bandwidth, speed, and then latency that provides, the low latency it provides, it makes all these changes into your life. But it has to be low cost. It has to be low power, because you're handheld devices. So basically, you cannot have a device that lasts only 1 hour. You need to last for the whole day, and it has to be low cost. That means you, me, and even everybody, at any income, whoever with any income should be able to have one of those. If
Yes.
you do that, then basically it makes this whole this whole infrastructure so efficient in future. And you will see a lot of new generation of the internet company, which basically use a lot of advanced intelligence to make decision or provide information happen, maybe even bigger than the company that are right now exists. You will see a lot of, search, a live search engine that basically search all of these IoT devices or, every person and provide information back to some other units. Yeah.
Yes, yes, no, you're right. Low power and low, cost is the key, but
The math. Yeah.
yes, it is, fundamental to be able to have a broader, usage of this and a broader infrastructure deployment. But if you look at IoT devices, they have many choices in the way they can access the network, right? I mean, one is if it's directly connected to the fiber optics, or if it's connected through 5G, 4G, any of those networks. So they may connect to network directly, or through a gateway, or
Yeah.
in a relay fashion. So if we comparing to these mobile devices like smartphones and iPads and all that, the security of this IoT device is very different. I mean, if they're using 5G network, because it has to these devices are small and cost effective. Sometimes they are just disposable and lightweight, and they have to still establish that trusted connection with the network. So how does that work? What kind of security challenges we will be facing in the coming years with these new emerging 5G business models? Because the IoT devices, they have no standardization, they are disposable, low cost, and they are going to be deployed in billions, in numbers. So the operating system and all that is also going to be very challenging, because you cannot encrypt that, and you cannot the security is going to be a huge challenge. So what
Yeah.
are your thoughts on that?
Yeah, I think this is not a problem with the wireless communication, or it's not a problem with 5G. It's a problem that basically on every link that these devices will have, you will experience. So how, is it possible that control device somebody else can control the devices, or basically manipulate these devices? Well, I mean, obviously, if you can break into any level of the network, for example, if some of these IoT devices controlled with the personal Wi-Fi system, local area network that you have. So let's say you have your Wi-Fi, and that Wi-Fi is a bridge to fiber or bridge to cable. If somebody can get into your Wi-Fi system and know the password, basically can get into your devices, right? So if there's a hacker and they want to get inside your home and your security of your home or your video camera of your home, and all it needs to do is basically a way to get into your Wi-Fi system, and then from there, if you have a Wi-Fi connection or your cable modem system, and then basically from there into your devices. Yeah, I think those kind of things at every level, the more level you have, the more chance a hacker can get into it. It just basically it can get at your home level, it can get at your a level higher and higher, all the way to the service provider. But if something like what Apple and other company did, so what they did is basically everything is basically go to cloud. And if you store all your information in cloud, everything. So there's only one location that basically the communication of my phone with the cloud, everything I have in cloud or everything, if it's based on that, then there is only one place that you need to make it very secure. And that's what basically some of these companies are doing. So if you have a very good encryption system and dynamic that keep changing based on, on over time, then it's harder to break in that. And management, it belongs to one big corporation that basically can handle it.
Sure.
If you deliver it to me to my home Wi-Fi, I choose any password that easily people can guess, or it's much easier. Or maybe like they tried million times, and then there is no like the way that the phone does. If you try 5 times, it's wipe out your information. Those kind of thing doesn't exist. So the smarter way of encryption and basically manage data, if happens and it's only one location, is much easier. But you're right, this thing always a headache. You see over time, people get into credit card information, people get into
Challenging.
so
Yeah. But the current approach that you say, with cloud, that makes sense. But in the coming years, we'll see the, emergence of neuromorphic chips. And for the neuromorphic chips, you don't need to go to cloud for to send messages back and forth. All the processing will happen right there on the chips.
Yeah.
So that is going to create different kind of challenge, because then if we don't know where those all those chips are going to be deployed for what use, and in how many numbers. So how to secure all that is going to be a huge challenge. And as we see, it's not simply about the medium of communication. It is these networks are a catalyst for blurring the boundary between cyberspace, aquaspace, geospace, space. So the 5G security design will need to be all encompassing, so that it can provide security protection for everything, the entire human ecosystem in cyberspace, geospace, space, and aquaspace. So do you see that with the technology infrastructure that we have, with the approach that we have, that we will be able to address all these challenges?
Well, I mean, and the 5G communication, which basically, can compare to fiber. Then you have a, fiber optic line, and then you send the fiber over it. Well, I mean, if I go and break it and look at the fiber, I get the fiber result. But then if the data that on the fiber is very well encrypted, or has a very good security, even if I receive the light, I won't be able to do anything with it, because I have to somehow map it into real data. And if it is scrambled, if it's in a way that is protected, I would never able to detect all the data. The same thing, and in every wireless communication. I mean, you can take those electromagnetic wave, and you can actually probe it, and you try to analyze it. But if you cannot find any correlation between the signal, the signal that you're receiving, any pattern or any meaningful pattern or correlation, then you will not be able to do anything with it. So at the level of the communication, it all depends on how you transfer, the data is managed. So based on that, and what data you want to be public. For example, when you do communication, at the beginning of communication, you have to have some public data. For example, you broadcast, my name is this, and then base station recognize it, and the next level, once you recognize it, start telling you that, I'm doing encryption, you have to do encryption, then they basically do handshaking and set up all those information. So the means of the transport media, it's the performance of the security of this all depends on how you manage your data, or how the data is going through that. So for the fiber, 5G, or any level, even if you had even if you have a telegram, if you don't encrypt the data, then you use the telegram, you could basically see the information. So the level of the security is depending on how you control data or manage the data, and how strong of encryption you have on it. It's not on the transport unit. That level, basically is a level that doesn't have much of intelligence to make it in a way that, it's how you manage that, and how you transfer the data over that media, or, the way that you're using it, it can make it more secure, but it's more software based, what you can do with the security, more than the media. Yeah.
Is that going to be sufficient to have a software-based security? Because I think depending on just software for security is going to be challenging, because we'll have to think of both digital as well as analog, how we can make the hardware secure, rather than just focusing on.
Yeah, I think that at that level is because all the data is digital, right? So basically, the way that you generate those data, it's basically you can create the security at that level, because the level that if I basically communicate, like let's say me and you communicate with just a hand waving, right? So if this very like a way of easy to detect what I'm saying to you, then basically everybody else can do it. But if we use a pattern that is not correlated with any ways of that me and you, anybody else can figure out, but only me and you can actually understand it, that's kind of like encryption. And that's what encryption was developed before. So it just, even just, hand waving or any signaling between me and you, if we have to make it secure, is me and you have to use the intelligence, because the light doesn't have intelligence. The sound, the way that the sound propagates there doesn't have intelligence. But the way that me and you use our brain to do that intelligence, that brings the security. So I think the security
That, that
yeah,
is the
it's
challenge, right? I mean, not everyone is educated or
yeah,
informed
yeah,
enough. So that is where the biggest risk is. If
yeah.
we all have that understanding of what to do, and how to operate our computers and not what to do and what not to do, then we'll be fine. But
Yeah.
that's where everybody comes from a different background, different level of understanding. So that's
That's true, and that's what we rely on the companies who managing our information to provide that security. And I mean, obviously, the more advanced the system get, the people on the hack also smart. The same people who generating these and then encryption and trying to basically come up with the best solution. They also are smart people use their mind in the wrong way.
yeah.
So it's a human. I don't think by the time somebody builds something after 5 years, other people figure out how to break it, or after a while. That's true. That's something that is not new. Even many years of even past history, any kind of the system, any kind of technique that people applied, then when there was later on there was something happening.
Yeah.
But yeah, I think the best. I mean, the intelligence brings. More, is more control, and you're right. I mean, like me, I'm not the expert in software, so somebody who is much better than me on software can create a better security system. And then the question is how long that can last and how smart it is. But this is a kind of like chicken and egg. You do something, later on happen to you. But I don't think the means of, like, having a car compared to driving a horse. The car obviously brought a big change to our life. A plane brought this these when you want to travel, it's headache right now. It's all because not the airplane, because of us that trying to abuse the system, right?
Yeah.
Or so I think we cannot blame the plane, we cannot blame the car, we cannot blame that means. It's just basically the way that we're using it is it's there are good and bad, and then how to control this is coming to the with the action. Yeah.
True, very true. Now, there is another, huge aspect of this for which I don't think I'm prepared to talk about it today because I haven't got enough time to do research.
Yeah.
So I'll have to address that in the, some other time. But it's about the fear of
Yeah.
5G. That it has a huge, there is a lot of information out there, information, misinformation, that it could, it's very damaging, this electromagnetic radiation, that there are a lot of dangers of 5G to the environment, to the human beings, to the planets, and all our human bodies are regulated by EMF signals. But what is it about the 5G and that radiation that impacts the human health?
Mm.
At least today, I'm not prepared to talk about it because I need to spend more time to
Mm.
understand
Yeah.
biochemistry and how the interactions happen between the electromagnetic signals. So that will be a topic of discussion for some other time, because this is a big topic in itself to talk about the health risk of 5G. There
Yeah.
needs to be proper understanding to be able to do some justice to the topic. So I'll talk about that some other time. But what are your concerns, as I mean, you understand the technology better than anyone.
Mhm.
To understand the advantages, disadvantages, where do you see the real challenges of 5G?
Well, I mean, as far as the challenges in the right, I mean, good way is basically how to deploy this and provide the coverage to every location. Because right now the major problem is the coverage of the 5G. Can we get the millimeter wave at every location that you want to use it? So that's the challenge, and then there's a lot of effort is going on to basically come up with a solution or address this. So that's a good way of challenging. And the other challenges that basically and then the other thing that it brought a lot of good to the table, the same thing airplane and the car brought to the table. But the other challenge is, yeah, I mean, managing all of these, like, when you have so many plane in the air or so many car in the street, now you have to manage this. Like, you need to have a traffic light, you need to have, air control centers and all of these. So basically, yes, there should be some, there should be ways of managing this data and controlling it and make sure everything's smooth. And then there is a lot of network level algorithm that developed to do that. But if some of these network algorithms have bugs, then things get disrupted. So for example, if the air controller make a mistake, two airplanes can collide. So there will be a while that this network becomes stable, and then make sure that the communication link is stable, and not only just delivering data, but it's not it's causing any problem. So those kind of things basically is under development, go through alpha stages, beta stages, become stable. So those are during the transition of maturing the technology. But as you said, there are also drawbacks that people can use this system because they're so quick to get access to every point, and then it's a real time you can control. Like right now you cannot control everything in real time. It takes a while, so you have time to. If something goes wrong, it can give you warning. You can at least you get notice. But when you have so low latency and so quick to every location, then as you said, it's the security of the system become much more important, because if somebody get the hold of something in real time, can control the whole traffic. For example, I mentioned about the traffic system. If somebody take over the traffic system, the whole traffic, the whole car, I mean, he can make accident at every location. He can make all of these things happen. The same thing that people are worried about, if somebody hacked our electrical grids, what happened to it? Yes, so these are the challenges that we have to make. It's like such a network that's so powerful. It has to also become very well controlled, well managed, and also secure system. You cannot, without security, it headache become more. Those are the facts. And then, as you say, the challenge of health. I don't think the health is challenges as concerned that other. I mean, personally, I'm not as concerned. But yeah, those are the one that people are worried about it. The same thing that when you want to go to airplane and you say, is going to have a crash or not. So to some extent, you have to say 99.9999% there is no crash. There is only small chance, like winning a lottery, that the plane can crash. But people only see that a very small chance, and they all worry. When they go in the plane, they worry about it. So yeah, so using such a system, a lot of people have an impression that may not be safe, or it may not be safe for health, or may not be safe because my data get somebody hacked to it, or just something happened to it. So I think both have a challenge. One is it has to be well managed and well controlled and well secure to give people can trust the system. And also for the health issue, people have to get more educated, and also the companies who make the devices has to also consider that what is the best way of applying the system. Because if you just look for making something and sell, it doesn't matter what frequency is, it can have a health issue. And then later on, 10 years later, you find this is a problem. That's no matter what frequency or what application. But if you from the beginning address this issue, it can be safe, and I don't see any major problem for that.
Yes, very true, very true. So, what would you like to tell our global viewers and listeners, especially about your new initiatives or what you're working on?
Well, I mean, in general, whenever I work on any technology, I was trying to do something that enable that market or that application. So back in '90s, I always thought that short range communication or any wireless communication will bring big changes. So having all these cables to your computer, or computer to printer, or and be able to communicate with no wire was a mass at that time, that the demands. And then I started to using a technology was actually able to do that. So I used like CMOS technology to make all the wireless system. And then you can see Bluetooth, Wi-Fi, and combo chip, and then all of these communication into one single chip that now apply in the phone, like iPhone, all the phone that exists today, using that. So it being a big change and makes a lot. Now people are relying on those. So I think that the 5G is another big change in our life, and that's the reason I choose this, because I enjoy be part of it. So now my challenge is to basically address all of this coverage and be able that you have access to 5G at even better than have access to LTE. So, and 5G has its own issue, how to get the signal at every location, how to get the signal from the outdoor to indoor, because that's going through the wall, going through the glass, and the windows are issues. So we basically have, addressing this, and then how to distribute the 5G signal within the offices, because I believe it's better than doing, and Wi-Fi will be in together with 5G. So 5G can be backbone of the Wi-Fi instead of fiber being backbone of the Wi-Fi. So there will be fiber backbone of the Wi-Fi or cable backbone of the Wi-Fi, but there will be a lot of hotspot in the street that you will see that you have a hotspot, but the backbone is 5G because there is no fiber location around that. So they use 5G as the backbone. But I think in future, it's better to have 5G device communication directly to device directly. Like, for example, if you have things like Apple TV or Google TV or devices that if you can actually go from 5G directly to that, it's more secure because you don't go through any Wi-Fi system. So the 5G will be supported directly with the, with the service provider or, Apple by itself or other company. So it will be much secure system and actually more efficient than Wi-Fi. So I think it's having the 5G signal almost to every device. It will actually change the way that we use, we're doing a lot of stuff today, and it will be more secure. So those challenges of bringing 5G indoor from outdoor, and distributed indoor or basically distributed outdoor every location. So you have the signal. It's a challenge that maybe a lot of companies have today, and we are part of and trying to solve those, address those things today. And if we do it, we will change the way that will live in the future. Yeah.
Yes, no, wonderful. So thank you so much, Dr. Reza, for participating in Risk Roundup today. We appreciate your thoughtful insight on the future of 5G, and our global viewers and listeners would benefit tremendously from the information you provided today. So even if a single decision maker can understand 5G based on the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you.
Thank you very much. Yeah.
Wonderful. So Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence and transformation happening across cyberspace, aquaspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. And it is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup video audio podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.